Hello from the Forcetronics YouTube channel. Welcome to Building Your Own AVR Arduino Internet of Things Board Part 2. This is Part 2 in a series of 5, and Part 2 is going to be a lot funner than Part 1 because we're actually going to build stuff, put stuff together, build a prototype of our design, and get it working. Let's get started. Okay, so my goal here is to kind of start simple and go all the way to a full prototype. So let's start by first programming the Arduino bootloader. So we have the Atmega 328P, and we need to add the bootloader to it, the Arduino bootloader, because the one I got, unless you already bought it with the bootloader, which you can do, but I bought mine from Newark, so it doesn't have the bootloader on there. I need to load it on there. And I'm going to be using the AVR Pocket Programmer from sparkfun. They have a tutorial there how to use it, and if you're using a Windows computer, I think you got to add a driver. There's other programmers out there. You can use whatever programmer you want. I'm just going to go use the AVR Pocket Programmer. I'm assuming you already know the basics of the AVR Pocket Programmer. Okay, here's our connection guide. You can see I added the AVR Pocket Programmer connections as well as the pins for our Atmega 328P, and then as a reference I have the Arduino Uno pins that it go to. And I got a little lazy in my picture and I just used red marks to show where I was connecting it up to. So once you get everything connected, you then do the programmer, add the bootloader. So remember, this is not a serial connection, so you don't have to choose a port. You're just going to go into the Arduino sketch, and you can just use a blank sketch. You go down to the programmer, make sure USB Tiny ISP is selected. I should say, make sure that's selected if you're using the AVR Pocket Programmer. You might have to choose something different if you're using a different programmer. And then you can see a picture of my connection and my program chip. You can tell from the picture that the chip has the bootloader on it, can't you? Anyway, keep in mind that the bootloader may take a couple minutes to load. Just to note, from the schematic, don't forget that you are going to need the resonator or a crystal oscillator like we talked about in Part 1, and you should also have the VCC connections. Okay, now that we got our bootloader on there, let's take another step. Instead of building the whole design, let's throw in a sketch. Let's do some more basic. Let's build our prototype out a little bit more, and let's test it with the blink sketch. Now note, one difference with the Pocket Programmer, the AVR Pocket Programmer, is you connect the reset pin directly to pin 1 of the Atmega 328P. Now that we're going to use our FDI cable or FDI board, we now have the reset connected through a capacitor, a 100 nanofarad capacitor, and then of course VCC going there from a 10 kilo ohm resistor. What else did I add? The only other thing I added that's different from the last one was I added a resistor and LED so we can run the blink sketch. Okay, so here's my setup. You can see my FTDI basic board connected to my USB cable. Here's my build up. I have the LED here this time. You can also see the capacitor that's going to the reset pin and the resistor going to VCC. Okay, let's check this out. And this is basically real simple. I loaded the blink sketch so we can see that the LED is blinking. Very exciting, but it's actually pretty neat. If this is the first time you've built your own Arduino chip, it's kind of neat to see it come together. So first we did the bootloader. Now we tested it with a simple sketch. Let's build up our design pretty much all the way, leaving out a couple parts that I'll mention. So now I want to build it up just about all the way. I added my DF Robot BLE Micro, our BLE board that we're going to use. All that's connected there is VCC ground, VCC, which now is 3.3 volts. I have my 1 kilo ohm resistors so I can program it through FTDI with the Bluetooth module still connected so I don't have to turn it off. I have my capacitors for filtering out noise related to my ADC. Oh, I have my LM317, of course. So I have that circuit hooked up. And remember, I'm not showing the complete circuit here in this picture. I'm just showing it as a block. In Part 1, we talked about the complete circuit. Now, what I did do is I pulled the resistor and LED off of the VCC in. And I had that there in our design to show that power was applied. I do plan to use that, but what I did was I'm now using that connected to pin 13 like in that first example because I'm going to use the LED again. Oh, and I should mention on the BLE Micro, I have it connected to a PCB board that I made. I'll link on my blog, I'll link the Eagle files if you want to download them. Okay, one thing to note is I'm not going to go into detail on the BLE Micro. I have a video for that. It's called Intro to Bluetooth Low Energy and the BLE Micro. Check that video out. That shows you how to get started with it. And I'm also going to use my example code from that video for our test, to test our initial prototype. And basically what I use in there is a sketch I wrote that allows you to turn on and off the LED from an iPhone or an iPad. So right now the only thing I have that has Bluetooth Low Energy is my iPad, and I have the DF Robot has an app where you can use it to communicate like a wireless serial connection with some of their BLE products. So that's what I'm going to use in this example, and I show the same thing in the BLE video. So I have everything wired up on my breadboard. Let's check out the setup, see the example, see our AVR or Arduino Internet of Things board actually work. Okay, here we are. I have it. I have the design connected to my power supply. I'm turning on my power supply. You can see the LM317 setup. You can see that big capacitor is on the output, the electrolytic. You can see other capacitors, and now I'm panning out and you can actually see the BLE Micro board. So I have the power wire to that and I have the serial connection. You're looking at my iPad and the app. So I press there and I type in on, but I remember it has to be lowercase. So there's on, and I'm going to press send, and you can see that it replied. I sent on, and the board replied LED is on, and now you can see the red LED is on. Then I'm going to type in off, and I send it, and I get reply that the LED is off, and the LED is off. So that's over the Bluetooth or the BLE connection. Okay, so our design is working. We put on the bootloader. We tested a simple sketch, and now we tested a more complex one using the BLE Micro. A couple notes I want to make, design changes. I kind of warn you that I'm doing this design in real time. So in from our part one discussion, I have a couple changes to mention. First of all, I'm not using the 1 mega ohm resistor in parallel with the resonator. I mentioned in part one that I might need that. I didn't even show it on the schematic. I did order the part though. It turns out I don't need that. I did some measurements and it's fine without it. The other note is I'm adding something, and this is optional. I'll say this is optional. I'm adding a 10 microhenry inductor in series with VCC and the AVCC input. And if you remember, I have a video series on increasing resolution accuracy in your ADC measurements. AVCC is where you feed in the reference signal for your ADC. So that's what your ADC is going to reference measurements to. And basically on the Arduino board, they use a 100 nanofarad capacitor. Well, an astute listener of mine pointed out that actually in the data sheet, they recommend you add an inductor to form a more complex, I'll say, low-pass filter to filter out high-frequency noise. So I'm going to do that because ADC measurements to me are important. I want them to be as low noise as possible. Once again, this can be optional for you. You don't have to have it there. The Arduino Uno gets by fine with just a 100 nanofarad capacitor. I'm going to add both. So I didn't show it in the schematic here, but when I do my layout, I'm going to use that. Okay, that's all for part two. In part three, I'm going to discuss the layout. And for instance, I talked about how we want this design to be flexible, and I want to be able to do prototyping right on my development board so I can, put the development board in different places and test it and have the little sensors or actuators, whatever I want on it, already on there. So we'll talk about that, what else I'm going to add from a prototyping standpoint, and any other changes right before we do the Eagle layout. Okay, if you like what you saw, subscribe to my YouTube channel. The code that I used for the testing the BLE Micro, well, I should say testing our whole Arduino Internet of Things board, you can find at my blog, as well as I'm going to add a link to grab the PCB Eagle files that I use for the BLE Micro. Those files are used at your own risk because I haven't fully tested them. In fact, I made a mistake on the one you saw in this video, but I corrected it. but I've not reordered the boards and tested it. But anyway, they should be fine. If you have any questions, feel free to email me. I'll see you for part 3. Thank you for watching.